Hey, what's going on? It's Bryce. I just want to go ahead and show you a notebook about how to do the fast gradient sine method in Python. So let's get going. So what we have here is a notebook that was built from before, talking about ResNet and transfer learning. So we have some imports, we have some transforms, we load our data into data loaders. We can see what the data set looks like. And then we can change the fully connected layer. We can retrain the model, throw it on the GPU. Great. We can look and we can train the model, save the model. Now, once we have the model saved, we can always load the model back up. But let's take a quick look at the results after having trained that model. So it looks like we get something like 80% test accuracy, which is pretty good, not bad after 30 epochs. And we can see what those plots look like. We can see that it asymptotically increases over time as the number of epochs increases. So the loss function decreases exponentially. That's great. So now what we want to do is we want to attack the model. We want to become an adversary and see if we can break the model in a sense. So we're going to use what's called the fast gradient sine method. Now you can go to pytorch.org and then in their tutorials there's a FGSM tutorial. So what we're going to do is define the FGSM attack as a function which takes in an image and some acceptable perturbation. And then we're going to use the gradient of the image in order to perturb, the gradient of the loss function in order to perturb the model or the image. Great. So the FGSM attack takes in the gradient sine and then takes a step in the gradient direction, and then it clamps down so that we remain in the image space. And so then we can test that over our data set, and we can see what the accuracy looks like for different values of epsilon. Now, if we were to plot the accuracy as a function of epsilon, epsilon is describing the strength of an attack. So we can see here that as epsilon increases, the accuracy of the model decreases. So for a very strong attack, the accuracy of the model is essentially noise. It's a random guess. And that's how you do the fast gradient sine method in Python. Have a good day.